Hi everyone, here is our math problem for today. Let's say we have here a heavy rope 60 feet long and weighs 2 pounds per foot. It hangs over the edge of a building that is 120 feet high. We would like to find how much work is required to pull the rope to the top of the building. You can pause the video and see if you can solve this problem. Now let's solve this problem together. Let's recall that if force is constant, then work is equal to force times displacement or change of position. Now in this situation, the force is the weight density of the rope times the length of the rope. The longer the rope is, the more work is required in order to pull the rope up. It is given that the weight density of our rope is 2 pounds per foot. So the work done here is equal to the force times displacement. Now going back to this rope, in order to use calculus, we are going to slice this rope into thin slices like this. The length of this rope is delta x. Now don't think of x as the horizontal distance and y as the vertical distance. There's only one variable here, and that is the length of the rope. So it doesn't matter if you are going to use y or x variable. If you let x be the distance of the rope, then dx would be the length of that thin slice of that rope. Now in this problem, think of this rope as comprised of tiny slices like this, and we would like to pull the summation of all those tiny slices up. So we want to know how much work is needed to lift this tiny piece up and then sum up all those work done. So how are we going to calculate the work done for each of these tiny pieces? We can easily understand it if we are going to look at the work done for a 1 foot rope. Since the weight density of the rope is 2 pounds per foot, then we can now calculate the force as that weight density times the length of the rope. So in this case, when the length of the rope is 1 foot, then the force is 2 times 1. This feet here and this feet here are cancelled, so the force here would be 2 pounds. Now, for this tiny piece, the force would be the weight density of 2 pounds per foot times the length of the rope here, which is dx. So therefore, the force is 2 dx. And since work is equal to force times displacement, if we now let the length of the rope from the top up to where we are going to select our representative slice as x, then the work needed in order to pull this tiny piece up would be force, which is 2 dx times the displacement x. This tiny piece is going to change its position by going up x units. And we can simplify this as 2x dx. And we would like to get now all the summation of all those tiny pieces from x equals 0 up to x equals 60. And so we now arrive at this definite integral. The antiderivative of 2x is x squared, and we are going to evaluate this from x equals 0 to x equals 60. And this gives us a value of 3,600 pounds times feet for the unit. So the amount of work needed in order to pull the rope to the top of the building is 3,600 pounds times feet.